about the organization, that is IRF Research Forum, Institute of Decision Journal Forum, and World Research Forum for Engineers and Researchers. It's been a NGO which has been a decade-old organization where we conduct conferences physically and virtually across the globe. So, talking about the organization more, organization is being decade-old organization and has around 10 plus peer-reviewed journals along with us. And here the organization has also been conducting virtual and physical conferences. And more than 750 plus virtual physical conferences have been conducted, and more than 250 plus virtual conferences have been conducted across the group. And to add on few more points, more than 75,000 papers have been published in the journey of the organization inception. And these are some of the statistics with respect to the organization, right? So as we were expecting around 8 to 10 participants today, but we have only 2 participants. Let us not waste much time. We'll just complete it off. If the other participants join, well and good. If we can go ahead and start up with the presentation. Let me also introduce myself. I'm a professor working working in a university in Bangalore. So associated with WRFER and IRF Research Forum from a decade, right? So we'll quickly go ahead and have a quick introduction of us, and then start with the presentation. Yeah, Mata, would you like to go ahead and?
Yes, can you hear me?
Yes.
Hi, my name is Mahtab Saidifar. I am a master's student of artificial intelligence at University of Georgia, USA, but I'm originally from Iran. And nice to meet you.
Same here, Mahtab. Thank you. Good to hear about your specialization, especially on AI. How that? Okay, we have one more participant join. Yeah. So nice to get associated with you. Right. So Satish, can you hear us? Would you like to go? We'll start up with the presentation then, without wasting much time. Mata, we can just share your screen.
Oh, okay. So, can you see my screen?
Yes, yes.
So, can I start?
Yes, please start.
Okay. Good afternoon. My name is Mahtab Saidifar, and I'm excited to share our work on automatic segmentation of birds using a combination of object detection and foundation image segmentation models, collaborating with STEAM co-authors Dr. Yuming Lee, Dr. Jin Lu, Dr. Linon Kai, Ramesh Bis, and Young from University of Georgia. So I want to talk a little bit about what image segmentation is and different types of image segmentation methods. So basically, image segmentation is a process in computer vision which divides an image into multiple segments to simplify its analysis. There are different types of image segmentation methods. We have edge-based segmentation, like canny edge detection, which defines the edges of an image. And then thresholding segmentation, like auto-thresholding, which uses the histogram of the image to divide it into multiple segments. And then region-based segmentation, like region growing, which starts with initial seed, and this seed expands until it reaches the boundary of the object. And then machine learning-based segmentation, like k-means clustering, which divides an image into k clusters. And then deep learning-based segmentation, like semantic segmentation and instance segmentation. So semantic segmentation basically assigns each pixel to a category label without distinguishing between instances of the same category. On the other hand, instance segmentation distinguishes between instances of the same category. So segment anything model, or SAM, is an zero-shot instance segmentation model, which was released by Meta AI last year. So it has been trained on extensive data set over more than 1 billion masks. So it's a promptable segmentation. It allows point, box, and text as an initial prompt. And also it produces 3 masks with different confidence scores for the output. So here's the flowchart of segment anything model. As you can see, the image will be passed through an image encoder to produce the image embedding, which contains the information, abstract information of the images. And then it passes a convolutional layer and it produces 3 masks with different confidence scores. So before going into the details of our current study, I want to talk a little bit about our previous project and its limitation. So actually the goal was to use a zero-shot image segmentation model for monitoring thermal conditions of individual cage-free laying hens. Actually, the goal was to evaluate the chicken's body temperature in thermal images. However, in order to do that, we first needed to segment the chickens from the background. So in order to do that, we first compared 5 different instance segmentation models, which are very popular: YOLOv8, Mask RCNN, Segment Anything Model, Mobile SAM, and Fast SAM. And we compared them in terms of evaluation criteria, and SAM turned out to be the best model in terms of evaluation criteria. However, in order to improve the performance of SAM, we added some pre-processing and some post-processing to SAM to first select the initial point of SAM wisely, and second, to select the best mask out of the 3 masks generated by SAM, regardless of their confidence score. So we use a machine learning classifier to do this task. So here's the result we got. As you can see in this table, SAM with pre and post processing has the highest performance among all the models, with success rate equal to 85%. So now the question is, not all data sets have thermal images to assist in finding the initial point for SAM. In these cases, how to automatically apply SAM on other data sets lacking thermal images. So the goal and objective of this study is to develop an automatic segmentation using an object detection model like YOLOv7 with SAM. So in this case, we use the information of the bounding box obtained by YOLOv7 to assist in prompting SAM. Here's the flowchart of this study. As you can see, it consists of 6 major steps. I'm going to go into the details of each step in the next slides. This study was conducted at University of Georgia's Poultry Research Center. 4 environmentally controlled rooms were used. Each room raised 180 chickens. The total number of images used in the study is 1,917. Here's some examples of our data set. As you can see, column A shows the RGB image and column B shows the corresponding thermal images. And then the next step is to use an object detection model, YOLOv7, to detect birds in the RGB image. So we chose YOLOv7 because of its speed and accuracy at the same time. And also we used the pre-trained YOLOv7 that already has been trained on a bird class from COCO dataset. So we didn't do any further training. We just used the pre-trained YOLOv7. And as you can see, column A shows the RGB image and column B shows the detected birds. Here's the flowchart of our proposed method. As I said, the image first will pass through an object detection model, YOLOv7, and then after the bird is detected, we use the coordinate of the bounding box obtained by this YOLOv7 to assist in prompting SAM. And then for the output, we just choose the mask with the highest score as the output mask. We compared our proposed method, YOLOv7 plus SAM, using point prompt and box prompt with different models, YOLOv8, Mask RCNN, and our previous project, thermal image plus SAM, thermal image plus mobile SAM, and thermal image plus fast SAM. And these are the evaluation criteria used in the study: precision, recall, F-score, intersection over union, and success rate. So basically, success rate here defines the number of successfully segmented images whose IOU are more than 50% over the total number of images. Here's some good results of using point prompt of YOLOv7 plus SAM. And as you can see, column A shows the detected birds. And for the point prompt, we choose the centroid of the obtained bounding box by YOLOv7 as an initial point prompt for SAM, as you can see in column B. And column C shows the segmentation result, and column D shows the ground truth. And here's some other examples of good result of using this technique. As you can see, column C is the segmentation result, and which is very similar and close to the ground truth, which is column D. And these are some bad examples. Actually, there are some limitations using point prompt of YOLO V7 plus SAM. So in few images, the centroid of the bonding box obtained by YOLO V7 is not located on the chicken's body, which leads to inaccurate segmentation, as you can see in column C. So these are some limitations of using point prompt of this method. Here's some result of using box prompt of YOLO V7 plus SAM. As you can see, column A shows the detected birds, and we just use the coordinates of the bonding box as an initial prompt for SAM, as you can see in column B, which is the segmentation result, and column C shows the ground truth. And these are some other examples. As you can see, the segmentation result of this technique is very, very close and similar to the ground truth, almost the same. And these are some segmentation results of different models. So as you can see, column G, which shows our proposed method, I mean YOLO V7 plus SAM using box prompt, has the most complete chicken's body compared to the other models. And this table shows the success rate comparison of different models. As you can see in this table, our proposed model has a success rate of 98%, which is significantly higher than other models. If you compare it with our previous research best model, which was thermal image plus SAM, which was only 85% success rate, our proposed method here is 13% more, which shows the reliability and promising result of our proposed method. And these are the segmentation results of our proposed method compared to the other models. As you can see, in most of evaluation criteria, it is significantly higher than the other models. So the proposed model showed very promising result with success rate over 98%, which is significantly higher than the other models. And there was no need for post-processing to select the best mask out of the 3 masks. So as we saw, the bounding box prompt has the best performance among all the models, and there was no training in any phase of this process. So since the chicken was one of the classes that YOLO was trained on previously, so we didn't do any further training. And this proposed method can be applied to a vast variety of images and can be generalized well. This project was jointly funded or supported by US Poultry and Egg Association and USDA. Thank you for your listening.
Today, my topic is survey and machine learning algorithms integrated with AODV routing protocol. So generally, AODV routing protocol, which works with the managers. So our AODV routing protocol generally works with manets. The manet is which is configured with mobile nodes without any infrastructure, pre-infrastructure. So my idea is to improve that AODV routing protocol by integrating the machine learning algorithms. That is the main motto of my research paper. So that is survey paper. And so I quickly go with the manets introduction. So it is a nothing but configuration of network with mobile devices without any infrastructure required. So one of the routing protocol I'm using with the manets is AODV routing protocol. As it is a more prominent protocol, it faces few challenges like mobility, due to the dynamic topology and limited resources. So due to these challenges, AOD is facing few problems. So I want to improve this AOD routing protocol with a new integrating with the machine learning algorithms. So before going to that, just I want to give a brief overview of AOD routing protocol. So generally, AOD routing protocol consists of 3 phases, undergo with 3 phases. One is route discovery, route maintenance, and route deletion. So the route discovery is mainly done by the 2 packets, that is request packet and route reply packet. So when the node sends the route request packet to the destination or to the neighbor nodes, until it finds the destination is found, the route reply packet will be broadcasted through its neighbors to the destination. Once the destination is known by the neighbor or the route reply request packet is received by the destination will reply the route reply packet to the source. So by using the route reply packet, it is going to establish a route to the source to the destination. So the route maintenance is done by the exchanging the hello messages. Whenever a route is failure, the route error message is sent by the intermediate nodes uh, or the neighbor nodes. And the next after the completion of exchange of the messages, the route is not required. That can be, we can find out the freshness of the route. So using these three phases, we can establish the route and we can maintain the route, as well as we can delete the route in the network. And next, so here I'm going to present the machine learning techniques which are useful to improve the AODV routing protocol. So generally, ML techniques are categorized into three, broadly three, but we can combine these different machine learning and make it as a fourth method, that is hybrid methods. So let us go with the first one, supervisor learning. So in the supervisor learning category, here the label data is used to train the model. Using this model, we are going to predict uh, uh, output. So here mainly in the supervisor learning, there are different algorithms. Mainly going to propose a few algorithms. So here using this neural networks, either using ANN algorithm or SSN algorithm, we can predict the link quality. So how much quality we can maintain the, using the by training that model, we can predict the link quality either using the ANN algorithm or SSN algorithm. So either next one is the decision trees algorithm, which is used in the supervised algorithms. So using these decision trees, we can classify the network so that we can predict the link failures very easily. So that we can avoid the routing the packets in the failed route, so that we can increase the reliability of the network. So based on this, in the supervising learning category, we can propose the two algorithms. One is neural networks, another one is the decision trees. And when we go to the unsupervised learning, so here we are going to use the clustering concept. So the clustering concept here, mainly in the unsupervised learning, we are going to use unlabeled data for predicting the output. So here, as it is unlabeled, so we cannot get any information about the data item. So we have to see the data sets, and the algorithm has to predict, train about the data by seeing its patterns. So we are going to, in the unsupervised learning, we are going to present the clustering concept here. In the clustering concept, we group the nodes which are, nothing but which are brings to one class, so that we can make that cluster as more reliable and no need to re-establish the route within that nodes. By grouping the nodes into one cluster, so we can reduce the establish frequently maintaining the route, whether it is available or not available. So we need to, we can avoid the route checks, so that to maintain the more secure network in the managed. So this clustering concepts we uses several many algorithms like k-means, hierarchical clustering, and PC algorithm, DB scan algorithm. So these are the algorithms we can use under the clustering concept. And next, when we go to the reinforcement learning, the Q learning algorithm we are going to use. So mainly before going to the Q learning algorithm, the reinforcement learning is the concept where we can use for the trial and error method. So using the trial and error method, we can predict the output for a given input, right? So in this reinforcement algorithm, so I want to present one of the algorithm, that is Q learning algorithm. So here we take the decisions for the optimization. So it observes the network thoroughly. By observing the network thoroughly, it awards the actions such that we can maintain the optimized routing. Nothing but by observing the total network, which route is better route, or which takes the less cost, and which the route does not have less failures. So it observes the total network and they maintain the patterns. It observes the patterns and it maintains a good optimized route for the network. So these are the three different concepts we are using in the machine learnings. So one is supervised learning, another one is unsupervised learning, next one is reinforcement learning. So next we present the hybrid models, other category of machine learning algorithms. So that is we combine the multiple ML algorithms, that is nothing but which makes as a hybrid method. So neural networks are combined with the Q learning. One is an example to maintain the hybrid methods. So let us, I have given the overview of the AOD routing protocol as well as the machine learning algorithms. So let us go with the case studies, which as we can come out with the make the AOD routing protocol more prominent. So as it faces many problems, so that I have studied with a few case studies. The first one is predictive AODV. So if we combine the neural networks with the AODV, we can predict the link, predict the link which are very good in quality and nothing but with the high packet delivery ratio. So we can using these neural networks, we can deliver the packet efficiently, so that we can improve the packet delivery ratio also. And the next one is if we include the Q learning algorithm with the AODV routing protocol, so we can optimize. We can optimize the routing. We can optimize the routing. Routing the network from one node to another node, so that the failure nodes will be. Failure routes can be identified, and most prominent route can be established using the Q learning, as it observes the total network conditions. Based on that network condition, it takes the decisions and maintain the optimal route. So using this Q learning algorithm, we can discover the optimal route, so that we can deliver the packets from source to destination very prominently. And the next one, we can use that cluster based AODV is nothing but we group the nodes which are under the network, which are exchanging the nodes, exchanging the information from one node to another node. So that nodes are grouped into one cluster, so that we can maintain the stable routing. Nothing but, so the nodes which are the route which is more successful, and nodes which are participating in that route will be clustered into one group, so that we can maintain a stable routing. So instead of checking every time the route is available or not, or the route gets any failure, so instead of checking the regular checks, we can maintain the stable route by using the cluster based algorithms. So these are the case studies we observed, and we can implement these algorithms to the AODV routing algorithms. And next, after integrating these algorithms to the AODV routing protocol, I can simulate the results either using the NS2 network simulator 2 or 3 or OmniNet++ by checking the metrics like throughput, latency, packet delivery ratio, and energy comes. Using these key metrics, we can check the results of the AODV routing protocol, whether we have any improvement or not. And next, we face few challenges while attaching these ML algorithms to the our AODV routing protocols. That is, first one is we should not make our AODV, MANET as overhead. If we attach the ML algorithms, it will be overhead. So we should make sure that it should be lightweight by using the ML models. So that is the thing we have to overcome. That is the first challenge. That is computational overhead. And next, that whenever the network is a real time, right, it is established dynamically. So our algorithms also should be efficient to adapt to its real time. Whenever a new topology is discovered, our algorithm should be adaptive to that topology. So it should be efficient while establishing a new topology. And the next one is security concerns. So in the middle, there may be several attacks. So our ML algorithm should be robust for the attacks. And next one is scalability. So if we are using for small number of nodes or small number of small, if we take the small amount of nodes, so it will be okay, ML. If we take the large network, our ML techniques also should be should perform the things for the large networks also. That means it should be scalable for the large networks also. So these are the challenges should be kept in mind, and we should integrate our algorithms to the AODV routing protocol. So finally, I want to conclude that so using this integration of machine algorithms with the AODV protocol will definitely enhance the AODV routing protocol in terms of throughput, latency, and with the stability. So this is my references through which I surveyed my things. Thank you, Ravi Kumar sir. This is my presentation.
Thank you for your presentation, sir.